So in this video, we are going to discuss the scenario called best compromise in feasible design. This message appears in the F06 file. I'm going to replicate this message for the first half of the video. And then for the second half of the video, I'm going to discuss how to fix this error that you might encounter. So let's quickly review the optimization problem statement. We are going to use the same objective function. We are going to start at the same initial point as before. This time we are going to define a new design constraint, and our inequalities for the design constraints will be slightly different from before. Here what we are saying is that we are going to have a function g1 here in the green ellipsoid and function g2 in the red ellipsoid. We are going to say that the solution is satisfied when the solution is within both the green ellipsoid and the red ellipsoid, or rather it satisfies both of these inequalities here. On first glance, you can see that there is no overlap between these two ellipsoids. But if we said that the solution has to be within both ellipsoids, but there is no overlap, such a solution does not exist. Well, you'll find out in a moment when I do this example with Nastran solution 200. You'll see that the optimizer discovers that it's unable to satisfy both of these constraints because it's impossible. What it does find is think of it as sort of it lands in between both of those constraints. That's why it's known as a best compromise in feasible design. Best compromise means that it sort of balances in the good term. It finds the middle ground between the constraints. When it finds out that it discovered the middle ground, but the constraints are still violated, it's termed an infeasible design. So let's go ahead and discuss how to replicate this example and how to fix it. So here we will go ahead and remove the side constraints or the limits on design variables like before. For the constraints, we are going to create our G2 or R2 constraint function. So here x1 minus 2.5 squared plus x2 divided by 2.0 minus 0.75 squared. And the upper bound for both of these is 1. So let's go ahead and delete these. Here, let me go to the exporter. I'll have this caution saying that I've defined the constraint, but I have not assigned it to a load case / subcase. So here, let's go ahead and click on this link. And here you can see that R2 is the one that has not been assigned to any subcases or load cases. I'll simply mark the checkbox. You'll see that the status marker goes from a yellow to a blue, meaning that error has been resolved. And you can see the error box has disappeared, so this is ready to be optimized. So let's go ahead and download this new zip file. Let's go ahead and extract the contents, and we'll go ahead and perform the optimization like before. Remember, this message, best compromise in feasible design, this appears in the F06 file. When you use the zip method to run Nastran, you'll get messages of your optimization. Here we have a red message saying run terminated due to hard convergence to a best compromise in feasible design at cycle number 4. So here we started at a value 25. At some point it discovered that the solution does not exist that satisfies the constraints. So the best it was able to do was obtain an objective value of 2.16. You see that the normalized constraints are still positive. Positive normalized constraints indicate that there is violation in some of your design constraints. Normalized constraints that are negative mean that your constraints have been satisfied. So here we have a normalized constraint of 0.733. Here we see the last values of our design variables. You see that at the very end we landed at 1.26 and 0.755. If we look back at the graph, let's see what happened here. And it's always a good idea to turn everything off. Here we started at a value of 3, 4, 25, and at the end we ended at 1.26, comma 0.755 with the f value of 2.16, and you'll see that those are the same values we had here in these plots. Now, what do you do in the situation when you have this message? This is what I recommend. You won't always have a graph to look at like we do in this example. You won't be able to visually graph it and discover that the reason for the violation is that the solution doesn't exist for this optimization problem statement. What I recommend in this scenario is to relax the constraint. So here, for example, if I take the red ellipsoid and instead of making the lower bound 1, maybe I make the upper bound 3. So this will increase the constraint ellipsoid. This will then overlap the green ellipsoid. And since there's going to be a overlap here, for example, in this small sliver that you see here, which is the overlap, those set of solutions will satisfy this optimization problem statement. So now how do you do this on a general example? So to start off with, if you go to the results section and open the F06 responses icon, this is where you can load an F06 file. So here, let's go ahead and load this. There will be a lot of data here. Here, click on active constraints. So this is going to show you all the constraints that are being violated for the given design cycles. So here, for the initial design cycle, we see that R1 and R2 are the two design constraints that are being violated. For design cycle 1, it's the same two constraints that are being violated. And this is repeated for the second, the third, and even the fourth and final design cycle. When you see these two or more constraints being violated, this is how you identify which constraints are causing the best compromise infeasible error message. So here again, what I recommend doing is relaxing some of the constraints, increasing the constraint bounds. And here, just to give you a quick example, what I'm going to do here is for the second constraint, I'm going to increase the upper limit from 1. I'm going to increase it to 3. So now let's go ahead and download this new version, and we are going to go ahead and run this new version here. And here, let's go ahead and see what the new result is. So what you will see in a moment you will see from this graph that what was previously a smaller ellipsoid or the constraint bounds were a little tighter. Once we relax or increase some of the constraints, we see that there is a small overlap where a solution can be found. So let's go ahead and inspect what our new results are. So first thing to note, the new error, or the new message rather, is run terminated due to hard convergence to an optimum. You can see the checkbox is green, indicating that the optimization went through successfully. You can see that the normalized constraints started at a positive value, meaning some error constraints were violated. But here towards the end, it landed at a value close to 0. In this case, it was even negative, indicating that the design constraints have finally been satisfied. So here we have a value of 0.84. Let's go ahead and jump back to the graph and see what the graph tells us the solution is. Here, if I zoom in, I think I might have to zoom in a lot. We see that we have 0.9, 0.17, and 0.84, and that's the same result that we have here from Nastran. So here you can see what the value is towards the end of 0.89 and 0.178. That's how it matches the graph. Now, let me show you one last thing here. Let me open up the F06 file. So this best compromise infeasible design message, this message will pop up towards the end of your F06 file. So here it says run terminated due to hard convergence to best compromising feasible design. And here, after we relax the constraints, we increase the bounds, we have run terminated due to hard convergence at an optimum. So that is essentially the end of these few simple examples. In the next example, or rather the next video, I will perform a global optimization example.